All right, welcome. Today, we're pulling back the curtain on one of those invisible pieces of tech that makes our digital world feel, well, instant.
You know that feeling, right? You tap a button on one app and bam, the result is right there. You load a website and everything just snaps into place. But then you use another app and you're just stuck, staring at that dreaded loading spinner. What is the difference?
Well, it's definitely not magic. It's actually a really clever strategy, a kind of high-speed shortcut that developers use to get the absolute peak performance out of their applications. It's this powerful tool that just sits there quietly in the background, making everything feel faster.
And that powerful tool is called a cache. Look, think of it like this. Instead of driving all the way to a massive central library every single time you need a fact, you just keep a small stack of your most used books right there on your desk. The cache, well, that's your desk-side library. And today, we're going to figure out exactly how it works.
So first things first, where do these caches actually live? It turns out their location completely changes what they're good for. Let's take a little tour through the different neighborhoods of the caching world. Okay, first up, we've got the external cache. You can think of this one as a massive, shared central warehouse. It's a totally separate service, often using super fast tools like Redis or Memcached that your application has to call over the network to get data. This is the go-to choice for really big applications that have tons of moving parts all needing to get to the same shared information.
And right away, we see the fundamental trade-off. The huge advantage is that this warehouse can hold an enormous amount of data, it can be shared by every part of your system, and it can grow all on its own. But what's the cost? It's travel time. Every single request is a network call, and that adds a tiny delay we call latency. Plus, you've got to manage and maintain this whole separate thing.
Next, let's talk about the in-process cache. Now, if the external cache is a warehouse across town, this is like keeping the most important information right in your pocket. The data is stored directly in your application's own memory. And because there's no network trip at all, it's incredibly fast. The advantage here is just pure, raw speed. We're talking zero network latency. But the trade-off is all about size and consistency. Your app's memory is limited, just like a pocket. And if you have multiple copies of your app running at the same time, each one has its own pocket, and their information can get out of sync real fast.
All right, let's move on to our third type, the CDN, which stands for Content Delivery Network Cache. Picture this as a global network of libraries. Instead of everyone in the world trying to get a book from one single library, say in California, the CDN places copies of the most popular books, things like images, videos, and web pages, in smaller, local libraries all over the planet, way closer to the readers.
The benefit here is pretty obvious, right? Users get their stuff so much faster because it's physically closer to them. But this system is really designed for static content, things that don't change very often, like a company logo or the basic layout of a website. And that makes it the absolute wrong tool for data that's constantly being updated, like, say, a live stock checker. And finally, we have the client-side cache. This one is like the user's own personal bookshelf. Your web browser or your mobile app stores things like logos, your personal preferences, and other data you access all the time, right? On your own phone or computer. That way, it doesn't have to keep asking the server for the same things over and over again.
This makes a huge difference for the user experience and takes a lot of load off the servers. But, and this is a big but, you have to be really careful what you store here. You would never want to cache sensitive data on a user's device, and you need to have a smart way to figure out when that cached data is old and needs to be updated.
Okay, so we've seen where caches can live. Now let's dig into how they actually behave. See, caches don't just store data. They follow very specific rules or architectures for how they handle reading and writing that data.
So the most common strategy out there is called cache aside, but you'll also hear it called lazy loading. And it's called lazy for a reason. The cache only gets filled up when the data is actually needed. The application checks the cache first. If it's not there, what we call a cache miss, the application has to do all the work. It goes and gets the data from the database, puts a copy in the cache for next time, and then sends it to the user. The application is in total control, which gives you a ton of flexibility.
Next up is write-through. Now this one is all about data consistency. When your app writes new data, it writes it to the cache and to the main database at the exact same time. It's a single operation. This guarantees that the cache and the database are never out of sync. For things like your bank balance or an e-commerce inventory, where being accurate is absolutely critical, this is the way to go. The trade-off? Well, writing data takes longer because you're waiting for two things to finish instead of one.
Now, if you need the absolute maximum write performance, you use Write Back. Imagine you're posting a letter. With Write Through, you stand at the mailbox until a mail carrier shows up and confirms they have your letter. With Write Back, you just drop the letter in and walk away, trusting it'll get picked up later. The application writes data only to the superfast cache and just moves on. The cache then handles writing it to the database later, in the background. It's ridiculously fast, but it comes with a big risk. If that cache fails before the mail gets picked up, that data could be lost forever.
And finally, there's read-through. This is a really clever twist on the cache-aside pattern we just talked about. Here, the application only ever talks to the cache. It just treats the cache as the main source of data. If there's a miss, the cache itself is smart enough to go fetch the data from the database, store a copy for itself, and then hand it back to the application. This really cleans up your application's code because all that fetching logic is handled by the caching layer.
So let's do a super quick recap. Cache-aside is your go-to for simplicity and flexibility. Write-through is for when consistency is king. Write Back is for when you need blazing fast writes and you're willing to accept the risk. And read-through is all about simplifying your application's logic. Each one is a different tool for a very specific job.
So, this all leads us to the million-dollar question for any developer, right? With all these different locations and all these different rule books, how in the world do you choose the right one?
And the answer, really the central theme of this entire explainer, is that there is no single best cache. There is only the best cache for your specific need. Every single decision is a balancing act.
It really just comes down to asking the right questions. For something like a social media feed, which is read way, way more than it's written to, cache-aside is a fantastic fit. But for an online shopping cart, which needs ironclad consistency, you'd probably want write-through. Is write speed the only thing that matters? Maybe for a real-time analytics system? Then maybe you take the risk with Write Back. Answering these questions, that's how you find the right trade-offs for your system.
And that's our look at caching, the hidden engine of speed all across the web. As we close out, here's a final thought for you. After hearing about all these trade-offs between speed and consistency, if you could cache just one piece of information in your own brain for instant recall, what would it be? Thanks for tuning in.